We are continuing the subject chemical thermodynamics. Whatever we have covered it, we'll discuss some question answer section. We'll take up 5 questions. In 5 questions, some short questions are there along with some problems. First, which of the following are the intensive properties? Intensive. First, you have to know what is intensive and extensive properties. Intensive properties are the properties on which the value of the property does not depend upon the matter contained. It is independent of the matter, amount of the matter. So, from the 4 options, that is viscosity, free energy, heat capacity, and boiling point, we can take up this viscosity and boiling point. Next, we'll go to the question number 2. Identify the type of the system as given below. Regarding the system, you have known the type of system as which are the open system, which are the closed system, and isolated system. In case of isolated system, no energy or matter cross through the boundary during the process. So that is called isolated system. But in case of open system, both matter and energy cross through the boundary. So in case of isolated system, no energy or matter cross the boundary to the surroundings or from surrounding to the system. But in case of open system, both matter and energy cross to the boundary. There is a exchange of energy and matter between the system and the surrounding. This is called open system. Open system. And in case of closed system, only energy can exchange between system and the surroundings. No matter. So this is called closed system. So now we judge what type of system it is. Hot tea poured in a cup of hot tea poured in a cup. So it is a open system. A is a open system is open system. Then B is the hot coffee in a thermoflask. Is a hot coffee in a thermoflask. So it is a isolated system. Isolated system. Then C, a tree in a garden. A tree in a garden is a open system. D, a refrigerator is a isolated system. And your hot tea kept in the kettle. So it is a closed system. Here only energy transferred between system and surrounding, no matter. Similarly, helium F, helium gas in a balloon. This is a open system. So these are the answers for the question number 2. Similarly, you take up the question number 3. The following, which of the following are the state function? So heat absorbed by the system and work done by the system, enthalpy of the system, internal energy of the system. Now, what are the state functions? The state functions are the function whose value depends upon the uh, initial state and final state only, not depend upon the path followed. So if we compare in this, we conclude that this is not a state function, and this is also not a is not state function. Heat or work is not a state function. Only state function is your enthalpy and internal energy. This is question number 3. Then number 4. If 8.5 kilojoule of work is done on the system, and 3.5 joule of work of heat is released from the system, calculate the change in internal energy. From what is the change in internal energy? First law of thermodynamics. Change in internal energy delta E is equal to your Q plus W. Here we take proper sign convention. This is your 8.5 kilojoule of work is done on the system. Work done by the system is negative, and work done on the system is positive. So this is plus 8.5 kg, and the 3.5 joule of heat is released. The release means heat lost by the system. The heat lost by the system is negative. So this is minus 3.5 kilojoule. This comes to up to 5 kilojoule. So this is 5 kilojoule. So the change in internal energy is 5 kilojoule. Then next thing is your question number 5. If a 5-liter cylinder contain 10 mole of hydrogen gas, 27 degrees centigrade, due to leakage, entire gas escaped into the atmosphere. Entire gas escaped into atmosphere. The atmospheric pressure is 1 atm. Atmospheric pressure is 1 atm. Then calculate the work done by the gas, assuming the hydrogen to be an ideal gas. Sure. Now we'll apply here the ideal gas equation to find the initial volume. Initial volume is your 5 liter. What is the final volume? When the leakage, gas is leaked, then there is a expansion of the after expansion. So what is the final volume? we apply a equation applicable to ideal gas equation. So here, what is the final volume? The final volume V is equal to nRT, nRT by P. P is equal to nRT. So here, N is number of moles 10 and universal gas constant is 8, 0.821, 0.821, and your 27 temperature degree centigrade 27 in Kelvin, that is equal to 273 plus 27, that is 300 K. So you can nRT, that is 300 divided by atmosphere pressure is 1 atm. 1 atm. Then this will be on calculation, this will be 246.3 liter. So what is the change in volume? Change in volume delta V is equal to V2. V2 means 246.3 minus 5. This liter and this liter, that will be 241.3 liter. 241.3 liter. We have to find out to calculate the work done by the gas, assuming the hydrogen gas to be the ideal gas. So we found this is the volume. This is the change in volume delta V. So what is the work done will be? Work done will be W is equal to P delta V. Here the expansion means it means negative. Work is negative. So P is equal to 1 atm. 1 into delta V is equal to delta V is equal to 241.3 liter atm. If you convert the liter atm, it will be 241.3 minus into, we multiply a factor 101.3 joule, 101.3 joule. If we convert this liter atm to joule, this will be this much joule. In total, this will be 24.4 kilojoule. This will be 24443.7. Means that is equal to minus 24.445 or simply 24.5 kilojoule. So value is this much. So work done is this much. So this is the solution of these 5 number of questions. And we'll continue to work out the numerical problems in our next class. And for the present, this much. And you try to practice more and more problems whatever theory is covered, you try to work out more and more problems so that your doubt will be clear and your fundamental concept will be strong. Okay, thank you.